Hello friends, this video on motion in a plane part 27 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos from part 1 to part 26 before going ahead with part 27. What is angular velocity? Angular velocity is the rate of change of angular displacement with time. We studied velocity, we studied displacement, but what is angular displacement? When I talk of a uniform circular motion, there is a change in angle which is involved with the motion. Just observe this motion carefully. We saw that this car moved from position P1 to P2, right? So what happened was the radius vector traversed the path sweeping out a particular angle. So what did we see? We saw that as the car moved from P1 to P2, the radius vector swept out a particular angle during the same time. So that let us suppose this angle is theta. So it covered certain amount of angle in certain period of time. Similarly, if the car keeps moving even further, so this angle also keeps increasing because the radius vector keeps moving about the center of the circle. So the angle swept also keeps changing. So generally angular velocity is denoted by omega. So we can say that omega is nothing but the change in angular displacement. That means this is known as angular displacement. Like when the car moves from P1 to P2, this displacement which happens, that is the distance from P1 to P2, from initial to final position, that is the linear displacement. But the angle which it covers while moving from one point to another, that is referred as the angular displacement. So the angular velocity is equal to the change in angular displacement divided by the time taken. So this is the rate of change of angular displacement. Now we will look at the relationship between linear velocity and angular velocity. How is linear velocity related to angular velocity? Now we know that linear velocity V is equal to the change of displacement with time. That means, let us suppose if we denote the change of displacement, we generally denote by delta R. So the change in displacement, the displacement per unit time. This is our linear velocity. Now from this figure we can say that, let us suppose that initially an object was at P1, later it is at point P2. Let us suppose while going from P1 to P2, it covers angle delta theta. And the linear distance which it covers, or the linear displacement which it covers, is say delta R. Fine. So this is delta R basically. And the radius of this circle is capital R. So from this diagram we can say that, what can we see from this diagram? We can say that from the figure we can say that delta R is equal to R delta theta from our basic trigonometry and geometry. So from your basic mathematics, you know that in a circle, this length delta R is equal to the radius into delta theta, that is the angle subtended at the center. Now if we put this value in the first equation, that is V is equal to capital R delta theta divided by delta t. So what will be delta theta by delta t? This will be nothing but omega. So V will be equal to R omega. So that is the relation between linear velocity and angular velocity. Now similarly, there is a relation between linear acceleration and angular acceleration. Linear acceleration, that is centripetal acceleration, and angular velocity. What is centripetal acceleration? As we derived earlier, it is V square by capital R. Now what is V? V is nothing but R square omega square divided by R. So this R and one of these R's will get cancelled. So this will be omega square R. So that centripetal acceleration can also be expressed in terms of angular velocity, which is equal to omega square R. Now we will look at certain numericals on uniform circular motion. The problem says a body of mass 0.4 kg is attached to a string 1.2 meters long and then whirled round horizontally, making 120 revolutions per minute. That is, let us suppose this is the string and this is the body of mass 0.4 kgs. So it is whirled in a circle with the help of this string. And it makes 120 revolutions per minute. So what are the values that are given? Mass is given as 0.4 kgs. Radius of the circle, because the string is 1.2 meters long. That means the radius of this circle will be 1.2 meters. So in the first part of the question, it asks what would be the angular velocity. So the angular velocity would be nothing but the total angular displacement per unit time, and it has already told that it covers 120 revolutions per minute. So angular velocity will be 120 revolutions per minute. Now what is one revolution? One revolution means covering an angle of 2 pi. Right? In one revolution it will cover an angle of 2 pi. So how many angle, what will be the angle that it will cover in 120 revolutions? It will cover 120 into 2 pi. Now using this we can say this will be 120 into 2 pi. This will be the angle covered and the time taken should be in seconds. So 1 minute is equal to 60 seconds. So this will be 4 pi radian per second. So this will be the angular velocity, because angular velocity is the angular displacement per unit time. So time is 60 seconds and angular displacement is how much angle will it cover. So in 120 revolutions it will cover 120 into 2 pi angles. Now let us look at the second part, that is we have to calculate the linear velocity. So just in the previous slide we found that linear velocity is equal to omega into r, where r is the radius of the circle. So omega in this case is 4 pi and radius of the circle is 1.2. So this comes out to be 4.8 pi meter per second. So this will be the linear velocity. Now let us look at what would be the normal acceleration. So in case of a circular motion, what is acceleration? That is nothing but v square by r, that is the centripetal acceleration. So v is equal to 4.8 pi into 4.8 pi divided by r is 1.2 meters. So this is 4. So this comes out to be 189.5 meter per second square. So this would be the value of acceleration. Okay, so now let us go ahead and look at the next problem. It says a stone tied to the end of a string 90 centimeter long is whirled in a horizontal circle with a constant speed. If the stone makes 120 revolutions in 20 seconds, what is the magnitude and direction of the acceleration of the stone? So here also we have a thread we have a string which is 90 centimeter long and we have a stone attached to it. Now it is again whirled in a circular path, somewhat like this. And it is told that it makes 120 revolutions in 20 seconds. So with the help of this value, we can calculate the angular velocity. So here what is given, radius of the circle is given as 90 centimeter, which is equal to 0.9 meters. Also, we are asked to calculate the magnitude and direction of acceleration. Now we know that acceleration is equal to v square by r, or omega square r. So if we know the value of v or omega, then we can calculate the value of acceleration. Also, it is given in this question, it is given that it makes 120 revolutions in 20 seconds. So we can say that omega, which is equal to 120 revolutions, means how much angle will it cover? It will cover 120 into 2 pi, because in one revolution it will cover 2 pi. So in 120 it should be 120 into 2 pi. And it covers this in 20 seconds. Because this angular velocity is nothing but the angular displacement by time taken. So this will be equal to 12 pi radian per second. So this will be the value of angular velocity. Now once we know angular velocity, we can calculate the value of acceleration as omega square into r, where omega is equal to 12 pi square into r. So this will be equal to 144 into pi square into r. So the acceleration comes out to be 1277.8 meter per second square. So this is the value of the acceleration. So we got the magnitude of the acceleration. Now what about the direction? As we already know that the direction of centripetal acceleration is always towards the center. So the direction will be towards the center. So I hope with these two problems you have got a better idea of how to solve questions on uniform circular motion.
Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.